So this is lesson 6.5, Use Proportionality Theorems. In the diagram, QS is parallel to UT, RS is 4, ST is 6, and QU is 9. What is the length of RQ? So, let's see. They already put the 4 in, the 6 in, everything's already labeled, and they did label that these are parallel as well. We're looking for the length of RQ, right here. So what we need to do is just set up a proportion. So RS is to ST as RQ is to QU. 4 is to 6 as X is to 9. So we can just put a variable here. Cross products and solve. 6X equals 9 times 4, 36. Divide by 6 on both sides, and we get X equals 6. So as long as we have a triangle within a triangle with these parallel bases, then we can just do this is to this as that is to that. So on the sheet rack shown, AB is 33. BC is 27. CD is 44. And DE is 25. Explain why the gray shelf is not parallel to the floor. So 27 over 33, if it's parallel, 27 over 33 needs to have the same ratio as 44 over 25. So you could reduce these and compare their ratios. That's one method. Or you can do the cross products and see if their cross products are equal. If their cross products are not equal, then they are not parallel. They are not similar. So if we went with the method of reducing, 3 goes in here 9 times, 3 goes in here 11 times, 9 elevenths. 44 and 25, does anything evenly go into both? No. So they're not going to reduce to the same ratios. That second method I was talking about is just doing the cross products and comparing them. If their cross products are equal, then they're parallel. If they're not, then they're not. 27 times 25 is 675. 33 times 44 is 1452. Those are not equal, therefore they are not parallel. The third method that you could also use would be to just put these into decimals. 27 divided by 33 is 0.8181, or 0.81 repeating. 44 divided by 25 is 1.76. These are clearly not going to work. So it is not parallel. This is not parallel to this because these are not similar triangles. Find the length of YZ. So we're looking for this right here. 44 is to 35 as 36 is to what? Cross products and solve. So we would have 35 times 36 equals 44 times X. Divide by 44 on both sides. And we get 35 times 36 equals, divide by 44 equals 28.63. Which is 315 over 11. Or 28 and 7/11. Sorry. Determine whether PS is parallel to QR. Determine whether PS is parallel to QR. If they're parallel, then these will be similar. So 90 is to 50 as 72 is to 40. So this would reduce to 9/5. Is this one going to be 9/5? What is 72 divided by 9? It's 8. Does 8 go into 40 5 times? So we're good. 72 divided by 40 is 1.8. 9 divided by 5 is 1.8. So we're good. They are parallel. In the diagram, angle 1, angle 2, and angle 3 are all congruent. GF is 120. DE is 150. CD is 300. Find the distance HF between Main Street and South Main Street. So we're looking for HF. So we're looking for this whole measurement here. So in order to find that whole length there, we first must find this measurement. 150 is to 300 as 120 is to what? So without even setting up my proportion, you might notice that 150 times 2 is 300. 120 times 2 is 240. So this whole length would be 240 plus 120, which is 360. If you didn't notice that it's a 1 to 2 ratio, you could just set up the proportion. 120 is to what? As 150 is to 300. Cross products and solve, and you would also get your 240 that way. So corresponding angles are congruent. So FE and GD and HC are all parallel. We're going to use theorem 6.6, and that is going to set up our proportion, solving for the 360 that we just did on the previous page. All right, so did you guys see what they did? They did HG plus GF over GF equals CD plus DE over DE. HG plus GF, right? Over GF. HG plus GF over GF equals this plus this over here. It's another method that you can use. In the diagram, angle QPR is congruent to angle RPS. Use the given side lengths to find the length of RS. So we're looking for RS. So on this one, we have the whole, okay, so this is a theorem 6.7, and it's using a pattern. The whole hypotenuse is to the leg, as the leg is the part of the hypotenuse closest to it. So we could use this whole amount, 15. Never mind, you can't use that. You can't use that because this isn't a right triangle. What you need to use is, if this is x and this is 15, then right here is what? 15 minus x. The other proportion I was telling you guys about, you can use, but only if it's a right triangle, and this right here is not a right angle. So we can't use that. So what we are going to use is 9. Wow, that's a 7. 7 is to 15 minus x, as 13 is to x. So 7 is to 15 minus x, as 13 is to x. Cross products and solve. So 7x equals 13 times 15 minus x. Distribute 13 times 15, 195, minus 13x equals 7x. Add 13x to both sides. 20x equals 195 divide by 20 on both sides. You get 9.75, or 9 3/4. Okay? Find the length of AB. 16 is to x as 15 is to 18. 16 is to x as 15 is to 18. Cross products and solve. So we're going to have 16 times 18 equaling 15x. We're going to divide by 15 on both sides. And that's going to give us x equals 16 times 18 divided by 15, 19.2. And on our next one, we are solving for AB. Because this one's a right angle, we are allowed to use the whole hypotenuse is to the leg, as the leg is the part of the hypotenuse closest to it. X is to 8 as the whole hypotenuse is to the leg, as the leg is the portion of the hypotenuse closest to it, which would be x squared equals 32. Square root, square root. So square root of 32, which reduces to 16 times 2, the square root of 16 times the square root of 2, or 4 rad 2. You might notice that this is actually an isosceles triangle. This is a 45, 45, 90. X, x, x rad 2. Is 4 rad 2 rad 2 8? Yes, because 4 rad 2 times rad 2 times rad 2 is rad 4, or 2. Rad 2 squared. Squared and square root cancel each other out. 4 times 2 is 8. So this checks out. It makes sense. And that was the entire lesson.